inventory item is already logged here. Pretty much. Okay. Hello, Spirit Storm and Ammo. So I have threadsafe. I'm actually working on threads. No, I'm working on utils, I think. Util threading. Excuse me. Oh, threading. Yeah. So working on this one. Okay, so this object tracker, this is example code. Let's just go down. This object tracker here is a template class taking a TrackedObject&lt, which requires that the TrackedObject&lt is actually a specialization of threadsafe unlocked, which is a template. Specialization is, well, yes, it's just, you know, let's say derived from threadsafe unlocked, or it is a threadsafe unlocked. Unlocked is usually the most derived class, so this is more like saying the thread unlocked is a thread safe unlocked. And then one that we're tracking. So it is a tracker that tracks an unlocked type. Then the tracked object tracked object has a shared pointer to the tracker, where tracker is this template parameter, and the tracker must be well, this type here, object tracker. It's not even mentioning the thing. It's wrapping to the top. So the object tracker class is not mentioned at all in this definition here, tracked object. It just has some tracker value, which that points to. which is created the moment I create my tracked object. There is no reference to it, but the tracker must have a tracked unlock type that is a base class of the current object. Not a base class, a derived class, I think. So we have some class that, oh my god, what is happening here? There's some class foo that is derived from tracked object, and then the tracker must be something that defines tracked unlock type. Yeah, which means that that must be an object tracker of this type. We're trying to access this. So I'm pretty sure that the tracker used below must be this object tracker, so that we can access that, which is then the template parameter of that object tracker, which in turn then is an unlocked. Yeah, also in case to be able to pass this batch here, this type must match the type that's being used up here. Okay, so tracker is an object tracker. To be one of this type. I would say that this is the locked type. So we derive from tracked object and then we wrap that in an unlocked. Which means that the lock is being taken before we can access the tracked object. Kind of makes sense, I think, yeah. And I'm especially interested, of course, in the functions that access the tracker, which is mostly the move constructor. What the hell? Okay, what is this? Oh, I just added that. This move constructor. These structures are less interesting. And these things, I don't know. I have to look at that later, I guess. Access tracker. Yeah, something is wrong with this part here, but let's look at that later. So let's look at the move constructor, and then let's say I have an object derived from tracked object that is wrapped in an unlocked, like I said, and that is the canonical object that the user is using or storing somewhere. Let's say in a vector, and the vector is resized, so that object, like that is the unlocked, is being moved. And I just fixed today that if you try to move an unlocked, it will right lock the original, and then call the move constructor of the protected base class, which then is the foo object, which then is being moved and starts with moving its base class, which is this tracked object. So we're calling this move constructor at the moment that the whole object is locked. And then we call, then we do the move while it is locked, ending with a call to set tracked unlocked. External synchronization is required. It's not allowed to move a tracked object while concurrently accessing the same object. Nothing is performed here. Okay, so I could add here then that typically you would wrap the derived class in. Let's type that in. So typically. Let me have a look again how that works. If I have actually the graph tracker. Graph tracker is derived from item tracker, which is an object tracker, so it is also a base class. And food tracker is derived from Yeah, now what we have to pass to the object tracker is the whole thing. I mean, it's kind of says here. It must be an unlocked, right? So I guess then here we have that again. Let me choose and where the tracker is derived. So object tracker is also part of this object tracker, of course. So that's also in utils threading. Let's write a little test for this, I guess. Because I'm not even using it yet. I can edit what I want. I'm gonna go to I have to work in the test suite, I'm afraid. Yeah, let's just move it to test suite. From here, so let's just get commit everything. Yeah, okay, I push that, so now I can go to AI thread safe test suite. That should sync with utils. It called that new file. And here I have a test for unlocked base. No, I don't want that. Yeah, what to do? Test if it still compiles. What? Nothing to. Just. No, I guess. How do we do that? In this file? No, why not? So this tests okay, let's just use foo or do maybe. Nah, foo. I need a tracker for foo now. Let me think. It's going to do an unlocked foo. Let's begin with this. I still have that. Wait a minute. Is it unlocked? Unlocked. I've got it already. What the hell? PS. S. We have utils. We have threadsafe. It's kind of totally not mentioning the new file. I did a resource, so why not? Alias as totally should do that, man. Object tracker.h resource make ctags. Why would this not work? What? Util threading is not there on this blind. I'm seeing thread save and I was seeing this and I think it's util/threading. Hello, Peter. Yeah, I need to make a new foo, I guess. And we need a foo that is derived from tracked object foo tracker. So I need a tracker and then derive foo from that. And tracker is then that. It's not easy at all, right? It is not easy at all. Source 1, 2, 3. Yeah, this thread safe test. What is so difficult about it? It's the last comment. You can donate me if you want to. Already, but the channel is not monetized. I hate advertisements, so I don't want YouTube to show advertisements. They better don't, because it's not monetized. But I thought I had a donate button somewhere. Kind of forgot where. So ask me again if you're really serious. I'll dig it up. You don't have to donate, really. Okay, I have this. Okay, yeah, let's make a new class. So here we have a few things. For need a new one. And this one is you need to derive from that, which means that let's call it tfoo, tracked foo, whatever. So that means I have to for declare that. And then we have that. I think this should work. Also need a policy. Yeah, let's just use I don't know. Policy read write. That's a long line. So now tfoo is tracked and thread safe. Unbelievable. Well, yeah. This is the unlocked type though. The locked actually. A locked type. Let's call it locked. Locked tfoo. Nah. Whatever. Right, so I'm just following the comment that I just wrote. So again, back to my comments. Threading. This comment. I need to make a foo tracker. Oh, wait a minute. That's object tracker. Now, foo is derived from this tracker. I think. Did I do this wrong? Is this my tracker? That's a tracker. This is the tracker. Damn it. I think I'll just copy this. Otherwise I keep switching back to it. Okay, foo tracker is derived from util threading object tracker thread safe unlocked foo and with the policy. Okay. So we can just do using now I have a tracker. And then we have to define tfoo for real. Tfoo is derived from that. And then it says, typically one should work with thread safe unlocked. Tfoo. That would be simply this type. So maybe I can get that type from the object tracker. Object tracker has a template parameter. That's the tracked type of the object. So we work with tracked type because that is the unlocked type. I'll call it unlocked. Unlocked tfoo. What this track type is then the type of the object tracker, right? Or wait a minute, what I just said. This one, object tracker. It's track type, and that is object tracker. That's a tfoo tracker. Now, let's see if this compiles. Error, no member threading. Well, maybe it helps if I would include a few headers. I don't even have unlocked, I think. Let's include that as well. I need thread safe for start. Oh, we already have that. And then I need unlocked. Already having unlocked here. Wait. Oh, sorry, I need object tracker. Include utils threading slash object. Tracked object, I think it was. Object tracker it's called. Object tracker.h. Requires clause differs in template redeclaration. That's a bug then in the object tracker.h. Previous declaration line 66. So I have a requires here for my tracked object. Oh yeah, I added that just on a whim and I didn't. I already had a forward declaration apparently. Not sure if I can do that then. Object tracker is probably not known where the forward declaration is declared. Totally not. Object tracker is defined here. It's a circular requires. Well, I'll try it. So it wants me to have everywhere where I have class tracked objects, which is only there, I need to have this line as well. So that would be that. But then object tracker must already exist. So now I must forward declare object tracker. Which is then, of course, these three lines. That might actually work. Just try that. Seems to work. I forgot a T here. Error cannot cast protected base class utils threading tracked object. Utils threading object tracker thread safe unlocked tfoo with policy read write to thread safe unlocked tfoo thread safe policy, same policy. Right, so unlocked is derived from tfoo, and tfoo is derived from tracked object with a tracker that uses the unlocked of tfoo. In other words, well, this thing here is the base class of unlocked. And it tells me I cannot cast directly from that base class to the derived class because the intermediate base class that's the base class of the unlocked type, aka tfoo, is protected, as you can see here. So just protect. And that happens in this line. Yeah, that's correct. You cannot do that. Why am I trying to do that here? Tracked object default constructor initializes a new shared pointer of the tracker. By constructing the tracker from a badge and a pointer. Yeah, I'm trying to go from the tracked object to the derived class. That should always work, but for some reason we're going to the unlocked type here. What? So originally this was a cast to the track type, which makes more sense if you ask me. That then is being passed to the tracker, where the tracker is this class which takes that thing as a pointer. And actually here, this one then. So it has a pointer to that template parameter. And here we have it's a tracked unlocked. It's the same thing, it's a template parameter. Pointer to the template parameter. So using the tracked unlocked type would be correct if you want to do that. Is that correct? I'm passing a pointer to that I'm storing here as a pointer. Is my object tracker indeed wanting to point to the unlocked type? This kind of doesn't make sense actually, because I should only dereference this pointer the moment the thing is locked anyway. So why return an unlocked type? It's already locked. It should already be locked. So if we return an unlocked type, then it like invites to lock that again, which would be a deadlock. So considering the fact that we want to return, well, we want to demand that we pass an access type and then it just return the unlocked type, sorry, the locked type directly. I might as well store a pointer to the locked type. Unlocked. I feel so stupid that I cannot wrap my head around this. Sure, I would think that this is simple 10, 20 years ago or something. Trivial. And now I just can't understand it. Let me think. I'm not convinced it is possible actually. But the current approach is wrong. The problem is that the tracker type the tracker type is supposed to give access to the underlying object by some reference. Because it maintains some kind of pointer to the object, to the real object, a tracked object that might be moved in memory by different threads. Therefore, if we use a tracker, then we really have to lock the mutex that protects moving and accessing that object before and dereferencing this pointer, whatever it points to. And then, while I was thinking just now, I had the idea that, well, obviously we need a single mutex, right? And the access can come from two ways, either by accessing the tracker or by accessing the tracked object directly. But both need to use the same mutex. So I'm going to need probably a mutex reference, a reference to a mutex. Plus, this is a pointer. So maybe I can use my Unlocked&lt that I wrote in the last month for the tracker. Because an Unlocked&lt is both. So jump there, Unlocked&lt. Unlocked&lt is both a pointer pointer hides in the base class here. There it is. It is a pointer to some type, and it is derived from policy mutex reference type. So depending on the policy mutex, I was just testing with a read-write policy. That would be this one. So is derived, so unlock base is derived from read-write ref in that case. Which maintains a pointer to the actual mutex, which you can access through mutex, which returns a reference. So we have a reference, we have two things. We have a reference or a pointer to a mutex, and we have a pointer to the object that we want to point to. So they are very, very similar, it seems. But how do you fit those puzzle pieces together? Again, let's try to follow that thought. That means that my tracker really should be a thread safe unlocked base. Which then takes some pointer and the policy mutex. So the policy mutex is still the same thing. That would be just this. And this type is then, well, whatever it's going to point to. And that, I was reasoning, should of course be the unlocked, the lock type. And well, that's just t-foo, right? The tracked foo. So I have a t-foo. Can delete this, I think. But yeah, I mean, can delete it. I mean, now it's not an object tracker. That is kind of strange, right? It's an unlock base. I mean, what, how? So unlocked became an unlocked base. We still have the t-foo and the object tracker disappeared. It's kind of sucks, of course. That won't work. Maybe I can introduce a new class that is going to take the place of object tracker and then just works with unlocked base. Yeah, I'm not sure how to do that, but I mean, not trivial at all. So if this is my tracker class, more or less, then what would this be? I'm afraid I have to work with also, you know, threadsafe unlocked for t-foo and policy. Doesn't mean that t-foo cannot be derived from some class here. It's like tracked objects. But I think it must be an unlocked type. So an unlocked meaning that you know you cannot access it, unless you lock a mutex first. Let's try this. Let's try this. So really, I'm working with an unlocked t-foo, which is then my unlocked foo. So maybe later I will have a nicer type there, but this is then the full type, more or less, or maybe not, but now even if I make why cannot jump to t-foo here? Is my threadsafe test also not part of my source functions? Unacceptable, of course. t-foo. So yeah, I could just remove this, and then nothing is tracked, right? It's just threadsafe now. The only way to access t-foo here is to create from the unlocked type. It's a big type, but okay. Let's say create a write access type, unlocked foo type w, create that from the unlocked foo type. And now we have write access directly to, wait, this is well, it's still unlocked. Wait a minute, that's nonsense. I just locked it, so now it's a t-foo w. And now we can access it. Yeah, nothing is tracked here. So I need to be able to access the tracker now. in fact, I need to be able to access the tracker without locking it. There's no need to lock the thing when creating a tracker. So before locking it, I should be able to get to make a tracker. So let's call that the tfoo tracker. No, tfoo tracker. Should be able to create that, and I wanted the type to be this one, tfoo tracker. Yeah, I need to, I need to be able to jump around here. So I need to add source. Just add source as well, source. Whatever. So the tfoo tracker is an unlocked base which can be constructed from an unlocked. This one is private, that is the class. So the only constructor we have is this one. You can just construct an unlocked, an unlocked base from an unlocked. Yeah, so this now is a class that has two base classes, tfoo and the mutex. Tfoo is protected. And this is a class that has one base class and a pointer. It points to tfoo directly. With some private member, and it is derived from a class that has a reference to the mutex of this object. So if I get access to my tracker, then I have to lock it first because it's an unlocked base, cannot access it directly. And then the only way to access the tracker is by locking that mutex. So that's now one mutex for tfoo and for the tracker. That's exactly what I want, right? Plus, it already has a pointer now. which is the whole idea. The only thing that doesn't work yet is that... Hey Len, oh, you're lonely. I'm like a teddy bear that you hold. Well, no, I'm not talking about holding me, but holding a teddy bear. You know, a little stuffed animal. Comforts. Watching my stream. Tifu. Yeah, the only thing that is missing is the whole tracking part. Meaning that if we move the original, this one, then the tracker must be updated. So the pointer of the tracker must be updated. And the way I used to do that, or well, the way I do that with the object tracker class, which I'm not using at the moment, is that the original, this thing, is derived from a class, TrackedObject. I'm listening to music with voice in it. No, Len, I don't know what you mean, but it's probably... I won't even say it. I just feel for David. Poor David. David gets a hug from me. Well, I don't have any friends, and certainly not friends that, I mean, in real life. Certainly not friends that understand even a little bit about coding. It is extremely difficult to find people that share the same interest when you're at a professional level of coding. You're not going to find any friends. Sorry to say, but except colleagues. So if you have a job as a programmer, then your colleagues should be your friends, because nobody else is going to understand what you're interested in or talking about. It's a nice thing of the internet that you are. That's way easier to find people with the same interest, the same level of knowledge or something. I think I'm on the right track here. I think I'm going to rename tfoo to locked, and then use tfoo for the unlocked type. Right. T-foo. So now we have a T-foo. Now we have a T-foo tracker which can be created from the T-foo. And I can access the T-foo by creating an access type like this, the normal way. This should compile, I think. Expected semicolon after alias declaration. So the semicolon there, that should be a semicolon, clearly. One thingy too much. Right. But now the whole object tracker thing was removed. There's no tracking going on here. How do we fix that? Yeah, so normally ignoring the unlocked stuff here, the object tracker would work like T-foo is just derived from from tracked object. So this would be derived from tracked object, which wouldn't do anything. It just derived from it. The only thing that it does really is intercepting the move constructor, so that if the T-foo is being moved, then we update the tracker. Or is there more going on? Well, it has a shared pointer, of course, to the tracker itself. Yeah, we cannot have a tracker here. The tracker must be immovable, something on the heap. So this line is nonsense. It must be allocated on the heap and well created at the moment you created t-foo here. And that is then also being done as part of the base class here, the tracked object. So the tracked object, I'm going to look at the non-threading one, so the old one. It's just a shared pointer to a tracker, and it creates a tracker. And if you move it, it intercepts it. And upon destruction, we set the null pointer again. The tracker is still there, so that well, whatever we do, so that we do the right thing, right, after destruction. It also has a member function to access the tracker. Okay, well. So then that code would look something like, instead of doing this, if I want to have my tracker here, I can do, I want to access it. So look again, what does it return? We have two things, either const reference or a reference to the tracker, depending on the current object. Well, it's not const here, so I can just get a reference to my tracker from the t-foo by calling tracker on it, which returns a reference, right? So it's almost the same thing, but the tracker is now allocated on the heap. At least it will be if we derive t-foo from tracked object and then make it work. Now the question is, can I derive locked t-foo from tracked object? I don't think so, because locked t-foo here is a protected base class. That's the whole idea. Do I need to protect the tracked object base class? I don't think so, because the only thing that it does is give me access to the tracker, which is also locked thing. It's an unlocked base, unlocked thing. Yes. I would rather have it as a non-protected base class, I think. It's probably even necessary. So now t-foo is publicly derived from threadsafe unlocked, which is protected derived from locked foo. And then t-foo is also publicly derived from tracked object, which will repass the tracker. And then the tracked object, just part of utils. I don't know if I need to make a new tracked object. For now, I'm not going to do that. I'll just use utils instead of utils threading. Yeah. That one now just has a shared pointer to the tracker. Which is the template parameter that we passed. And it will cause the tracker to be created. And this time this should work, the cast, because now we're casting from a public base class. So yeah, it definitely has to be public. So that solves the last problem as well. And we have our tracker member functions. So as long as the tracker is an unlocked and well, it is an unlocked base, we are completely safe and done here, right? It looks actually pretty good. So we have to pass something that is an unlocked base here, and then everything is okay. Except that I didn't look at the move constructor yet. So yes, we do pass something that is also locked, unlocked. Keep confusing those. But unlocked must be constructed with an argument. It must be constructed from the unlocked. So it's good that we do it in this order. This being the first base class, so the unlocked is then already constructed, and then it can pass that to the constructor of this. Well, it must be passed to the constructor of what this thing here, and is that working? Doesn't look like it. Make shared batch, comma pointer. Well, it casts this to, what the hell? That's not going to work. You cannot do this cast until that type is complete, and we are in the middle of creating the thing, I think. Sure. Yeah, that's not going to work. Let me throw this away. Oh. Right. Difficult. Yeah, so at the moment that we create this thing here, that contains a static cast from this pointer. That would be the tracked object that I highlighted. And we need to pass to the standard make shared the argument, the constructor arguments of this thing, and that is this one. So we're trying to cast from here to, well, actually to here, and then we pass that, and then it's going to say, okay, you pass a t-foo, but I need an unlocked, so and then that is implicitly converted to the unlocked. However, I'm not convinced that was going to work. Plus, we don't have a t-foo, right? Because what this is actually doing is casting to the tracked type of the parameter that you pass. And t-foo tracker doesn't have a track type because it's just an unlocked base and not derived from object tracker. So we still need to create an object tracker, make an object tracker class of this, without losing that it is an unlocked base. If only to add that class. Maybe I should do like temporarily simply add a type. So make this a base class, and then I'll tracked type, add that, and we need, I cannot cast it from here to there, of course, so I have to cast it to the t-foo first. So we need a forward declaration of that as well then. However, I already changed this now to threading here. So really we're using another thing. I'm using tracked object in the other namespace, this one, which casts you tracked unlocked type. Nothing wrong with that, I suppose, because t-foo is in the end indeed an unlocked type. I'm just not sure that this is going to compile at all, because classes might be incomplete at the moment that it is being instantiated. Let's have a try. Constraints not satisfied. Template tracked object or tracker's t-foo tracker. is specialization of object tracker evaluates to false. Food tracker is not a specialization of object tracker. Oh, that's correct. I was literally saying, well, let's not do that yet. What shall we do? I guess the food tracker must be derived from object tracker for this requirement. But yeah, well, I can rewrite that. Let's start with removing the requires, because in the end I probably need it. But do I really? Okay, so I have two of them. What do we need of tracker? We need a tracked unlock type. I added that one. Yeah, that's all. cppgraphviz. I've been working on that for a while. The idea is that generates a graph of all the object instances of your program. Yeah, you have seen the images, no? Like something like this. It's not a graph because they don't have any edges yet. But here you can see that the instances that I have a C and a C2 and a D2 and the members of those classes. And I have an array that takes a index as index, and that I have two arrays like that. And these are then the labels of the elements. And we have, well, three other variables here. Way too difficult. I don't know why I'm writing it. Well, I know why I'm writing it, but should not have done that. It's too difficult. Let me just remove this requires for now. Yeah, both. I needed to find a bug, so let's call it debugging. No matching function for call to construct add. Instantiation of function template specialization, standard construct. Instantiation of functional template specializations, and then make shared tfoo tracker requested here. So what is this telling us? It cannot create this tracker with this badge and this pointer. So that works apparently, that cost. So surprising. Candidate template ignored, substitution failure with TP's food tracker, and arguments is that badge and the tfoo pointer. No matching constructor for initialization of tfoo tracker. No matching constructor for initialization of tfoo tracker. You said that. Why does it say it twice? Candidate constructor implicit. It's not even talking about the real constructor. What the hell? So it's complaining that it doesn't have a constructor for tfoo tracker. Oh, that's correct. That is totally correct. I never added one. Right. Okay, well, yeah. Let me think. Stuck tfoo tracker. I guess I should just make it a using, right? Using tfoo tracker is something, and then might as well just completely rewrite that clause. Okay. I don't know. Try this one. Try something. So the using here wasn't bad to begin, but I have to just rewrite this clause, I think. So I'm going to use utils threading object tracker, and then we need to end with basically something that is derived from unlocked base. Unlocked base, locked tfoo. One, two, three. Okay, so it should work. Except now I have to rewrite this object tracker so that this becomes a base class. It must be a base class because, well, it doesn't really have to be a base class now I think about it. Nah, it doesn't have to be a base class. Let's have a look how this looks like. Object tracker. Utils threading object tracker. Control N. There we are. Type name tracked unlocked is a specialization of unlocked. That's wrong, so there must be unlocked base then now. and then I'm using that as yeah, this was my pointer, but now I'm going to replace my pointer with the unlocked base, right? So I have a pointer here, and this is stuff. So, yeah, it's the only member variable here. And I'm going to replace it, although it's not atomic for nothing, so that kind of sucks. I don't think my base pointer is atomic. It's no longer a pointer. Right, so this thing is now constructed from the unlocked that we pass to this function, which must have a certain type. What is the bloody type? The unlocked base. Unlocked base is a policy type and a const unlock type. I think I can use this one. This const unlock base, not a base class. Oops. Const unlock base is a base class of unlock base, I think. Yes, it is. So we can pass an unlock base as well if I take an unlocked const unlock base. And I think I can just construct from a const unlock base. Yeah, probably. Probably. Let's define that one. So we have a const unlock type. And this is my attract const unlock type. And now I'm going to pass a track const unlock type const reference. I'll just add a const here. No, I'm not sure I'm happy with the const though. Does it make my base const? Should make it const. It means that I cannot access it as a non-const. Reference to whatever I point to, which is not what I want. Definitely need a non-const type. Guess I'll have to add one. I need non-const unlock type. I think I can just make one here, unlocked. Data type. Yeah, I think it's pretty safe to add my requires back here, right? So, don't think I need that anymore. I mean, don't need it anymore that it's commented out. Now I've got what else I was editing. This. Okay, now this the threading object tracker has an tracked unlocked. It's a template argument. That's in unlock base. So not base class then, but just a member. And we have to construct that from the unlocked type. Wait a minute, actually I needed this one. Let me do that first. Oh boy. Guessing I'm not using this yet, or am I? Probably not. Let's comment it out for now. This comment says used by trackers that are derived from object tracker. Yeah, okay. Well, I think I can leave it in for now anyway. It's the same thing as this one, except this one's public with a badge and that one's protected, so no change there, no difference there. And the object tracker here now needs to be passed tracked unlocked. const reference. Hopefully that will be this one, right? I'm passing it to t-foo. And that is still the unlocked. Unlocked is, it was an unlocked type, so that should be this one. Show me the compile errors, because I lost it. Requires clause differs in template redeclaration. Oh yeah, I added the base here. I forgot that to do that here. Error use of undeclared identifier tracked unlocked type. Oh yeah, first I returned it around. Well, I guess I should get these now from the unlock base. See, unlock base has them also. Policy type, it has a policy type, does not have a data type. Oh, wait a minute, it cannot have a data type. That's problematic. I need to get this from the tracked unlocked. Is it not like literally the tracked unlocked then? What are we passing to object tracker? Nope. Object tracker, oh, we're just passing an unlock base. But yeah, on the other hand, you know, this type here, which is base class, should match that one. So it's really the data type in this case. So if we can access the base type from the unlocked base, then I have the type and then I just add that to unlocked and then we still have it. Although I'm not sure if I want to do that, but yeah, what can you do? Maybe I should convert the unlock type to the base internally. So not pass unlock base here, but pass unlocked. Then I have all the types and I can create my own unlock base. So we remove the unlocked. I remove the base from my object tracker. And then it can no longer be a base, or is no longer a base, it must be an unlocked. And then the tracked unlocked here is no longer the correct type. Where am I using? Wait, that's nonsensical. No, that's correct. So that's the thing that I'm passing here. Yeah. I'm not using. Okay, cool. So we need here using the tracked unlocked type. Yeah, setting that to okay, I'm just setting it to that. Then we can get the tracked type is the data type. And then we do tracked. I'm gonna call this base, I guess. So we created our own unlock base type. And that's then the one that we want to use here. Although I'm not going to call it base because it's not a base. I call it pointer. Okay, the DIFM is just absolute bonkers. There's vocals in absolutely everything. So let me put on my own music. So much better. A bit loud though. Okay, where am I? I think that should work. My thoughts on std print, subprint. You mean printf maybe? I don't know. Standard print. I had not heard of it. Standard format string. That's interesting. There's no link to standard format string. Bit unclear. I don't know how this works. Yeah, well, I know. My main concern is that you can only print built-in types with it, which I think is ridiculous, useless. Looks like it. But yeah, maybe not. I don't know. I don't know, man. I think that people just didn't like the object-oriented outputs to an O stream, and then they just kept pressuring, and they kept pressuring, and they kept pressuring the committee until they finally gave in and said, well, whatever, here you have something to shoot yourself in the foot. But yeah, why not? Because you can also not use it. So they just had to add it anyway, right? It's not like it hurts me. And I guess that for simple programs, it's easier to use. As long as you just want to print quick things, you know, short programs, tutorials, you just want to print a string and an integer and nothing else, then it's probably way easier to use. But if you want to print one of 300 different custom classes that you made, yeah, then you have to use standard cout, of course, or O streams in general. And the main problem with printf, so the C thing, is that it uses a different buffering. Like the main reason that you should not mix C style IO and C++ style IO is that it just messes up your output unless you turn off the buffering altogether, so that every single character is one by one sent to the terminal, which is pretty slow. But that argument goes away, I guess. I mean, if they support it through C++23 or whatever, then it's of course using the same buffering of the other C++ I/O. So then it's perfectly okay to use it, to mix it, and it will be as fast as when you don't use the C printf. You just get an easier way to format output of built-in types. So I guess it doesn't have a downside to add it. I'm not sure if I'm going to use it. Maybe. Probably I will use it for quick hacks, like little test program for which I quickly have to print something that is formatted and exists of purely built-in types. Then I might use it. Static goes from utils threading tracked object, utils threading object tracker, threadsafe unlocked, pointer, to object tracker aka unlocked pointer, which is not related by inheritance. Yeah, I guess the static cause is happy, a bit too happy. Tracker tracked unlocked type, that would be this one. Now I have to do this one, I think. Track type. I think so. Oh. Static cast from the tracked object, blah 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 blah, pointer to locked tfoo pointer. So it's telling me that the locked tfoo is not derived from tracked object. I think it is. So actually it's commented out, so it's not. Yeah, what did I say? Tracked object, right? Yeah, tracked object. So it should be derived from tracked object tracker. And I'm gonna assume that object tracker, yeah, that was made from an unlocked and so on. This should work. Tracked object. So if we derive this from utils tracked object and then the tracker, then we it should be good again. Except that it doesn't work at all. I want to cast to tfoo, not to lock the. How do I cast to tfoo? I don't have a tfoo. I have a lock tfoo. Why do I have a lock tfoo? I only have a lock tfoo because I only have a food tracker here. And the food tracker is an unlocked or locked tfoo. Yeah. I'm just going to pass this type here. But I'm declaring it here. I need it. I'm going to pass it, right? So tracked object, sorry, but tfoo. So now tracked object must take the locked tfoo, no, the unlocked tfoo as well as first template parameter. Data type. Yeah. So the data type is called track type. Let's use it. Let's call it track type. Obviously, let's call it track type then. Tracked type. Mm-hmm. Well, I could add a requires that the track type is the derived type of this type. But yeah. Too many template parameters. Not previous template is defined there. Type name, tracked type. Too few template parameter. Templates. Too few templates arguments for class tracked object. I seriously change that thing here. Example code. Tracked object is track type is extra template parameter. No, this is missing here. Yes. And we have the track type there, and we have no track type here. Wait, this is the good. It's just the tracked object. This tracked object. That was it. No matching function for call to construct add. Construct add, construct. Shared pointer. Note in instantiation of function template specialization, synonymic shared. Okay, we cannot make a tracker. It would be nice if it said what tracker was. I guess it's gonna say later. In instantiation of Mango member on blah blah blah. Oh, there we are. No, candidate template ignored. Substitution failure. Still, we don't know what it's trying to make. What does it say here? TP, yeah. I think this is the one that's trying to make then. Object tracker. I guess this is the problem here. No known conversion from batch tracked object t foo and the rest we don't need to know. I think that so many people are not able to read these kinds of errors that they started to abbreviate it, the hell out of it. Like nobody's reading it or understanding it anyway. You might as well use ... Hello? I want to see what this says. That is highly annoying. Highly annoying. You'll have to guess your way through the errors here. Candidate constructor not viable. No known conversion from batch tracked object t foo. Nobody knows. To batch tracked object util threading object tracker. Okay, at least there's something different. T foo looks perfectly okay, and then here we are talking about object tracker. This is a single argument, right? We are accepting a batch. No, it's a batch object tracker here. Batch with 2 arguments. No, wait, tracked object, yeah. Batch tracked object. Tracked object t foo. Yeah, object tracker. It's nonsense. This is nonsense. Don't tell me that track type is the object tracker. No. No, I think it's not. No. I hate this. If this would just spell out the same type as I see here, then it would be way easier to understand. Oh wait, tracked type. Oh wait. Oh, now I see what happened. What it's doing here. Yeah. So the track type is not equal to t foo. It would be nice if it just said what it was. What is track type? No, I think track type is your locked t foo, so that's not correct. So we have to find a batch that uses track type probably. I guess that's this one. And that is not what I want. No, what? type tracked unlocked type not object tracker. The data type of the tracked unlocked, that is passed to object tracker. Yeah, that's locked full. Well, I'm happy to use locked full. That would be the type, I guess. Then we are again to where was I passing that? You're passing that here. Tracked type. Yeah, this is where it receives it. So I need to. Where do we call this then? Yeah, that's not, no, that's not how it works. I want to pass tracked object here, but because that is the object here. It's the only way how it works. Which means that I need this type now also in the tracker. Talking about annoying, just to satisfy my batches. Oh well, I'm getting sick of it, so let's just add it. Object tracker, don't add the bloody track type also to the tracker here. track log type, and then the track type is now the correct one for this, for the batch. And I still have to add it, the template parameter, to my object tracker. So I'll look for that one. T-foo. No matching constructor initialization of log t-foo. In instantiation of function template specialization, threadsafe unlocked, locked t-foo, comma, no, locked t-foo pointer. Yeah, this is a const reference, which I need, so let's pass it. I'm just dereferencing this, and I guess the cost. What is this? Set tracked. Yeah, just there. I don't know, man. Well, that worked. So now my tracker is an object tracker of t-foo. T-foo tracker is an object tracker of t-foo. No, that's bullshit. I just add that for kicks. It's an object tracker of an unlocked locked t-foo. I'm just passing types here. What is being done with those types again? Object tracker, now I have two types, tfoo and the unlocked locked tfoo. Okay, the last one is what we actually point to. That's not, oh, then it's even created. So that's an important type then, okay? So we point to something, a shared pointer that is being created on the stack. That definitely, it's just a type of the tracker. Okay. The track type is not really used. It's just, oh, we do use it. I'm casting that. Using that as a cast thing. Yeah, which is also required. Or not. This is my tracked object. Thought I was talking about the tracker. Object tracker. Tracked objects. I think I'll need to rerun this. Object tracker. Threading object tracker. This one, yeah. Tracked unlocked. Track type. So the template parameters are defined as it is to. That one is just used in a batch. It's totally not interesting. And the other one, also used a lot more to get extract other types, but also as the unlocked type that we create the unlocked base from. Yeah, okay. Gotta wonder why I'm not having a tracked object here. Oh, that's because I'm not supporting moving yet. This compiles, but that's about it. So now by tracker is at least a threading object tracker. And my tfoo is an unlocked locked tfoo. I'm happy with that. And even a tracked object, even happier. So this seems like, well, finished. The finished type. This is not finished type yet. Probably have to add that part that is commented out. And then at the end of main, I'm trying to do something with it. This creates a tfoo, which also creates a tracker on the heap. And we can access it like this, so that still works. We can also access it like that. I should also be able to access it through the tracker. For example, the object tracker gives me used to give me accessors here. Is my set tracked unlocked already used? It should be used here. Just being called here. Okay, let's add the accessors back, and this is object tracker. No, please work, because otherwise all this work was again for nothing. Because sometimes the pieces of the puzzle just have to suddenly all fall in place, and if that doesn't happen, then the day was wasted. Okay, so before I get access, no, before I even dereference this thing, which doesn't exist anymore, I think. Oh wait, that was my brilliant insight. It's now an unlocked base. But still, this thing has a pointer that is going to be changed. So before I even read the pointer itself, aka access this thing, I must already lock the mutex. I'm pretty sure I cannot do this anymore then. That does not take any arguments. It just converts it to whatever type you put here. And I think I need to pass an argument, as in an access type, in advance. Or I don't do this at all, and I just demand that we... Oh, no. I think my plan was to return an access type. To not return that, but to return the an access type. which, as long as it exists, has the lock. Yeah, and that must have been my my goal here. So what is the access type? The access type is, let's do first this one. Let's do one at a time. The access type here is, I think I have an unlocked type here. Yes, it must be a specialization of unlocked. But the real type is this one, unlocked base. This is the real type, of course. Yeah. So I'm going to return an access type for read-only access. And well, by value, and then we just return, well, we have to create that from tracked unlock pointer. Now I have to think if I want to return a CRED or a red. If this object here is const, what does that mean? Then I have a const object tracker. Do I even care? I'm gonna call this one const unlocked, maybe. If it is const, then this thing is const, and then I think I can only construct a CRED from that in the first place. Or not. Actually, no, that depends on... Oh boy, I have two of these types. I have an unlocked base now. I should have an unlocked, a const unlocked base, maybe. So now suddenly I need a const object tracker, which then looks the same but uses a const unlocked base. I guess the trick is I need to turn this into a const object tracker and then do the usual trick. Derive from it as object tracker. And use that to give write access. Trying to think, what do I need a const object tracker for then? For const access, I guess. Read only access. Well, let's not do that yet. By not doing that yet, I mean I'm giving non-const access. So that means that, let's say I'm going to return a red because I can. I think I can. And then this one is going to return a what, also by value. And then I might as well do these as well. Tracked unlocked, base type, red. And what? Oops. Oh, right. And then Control T. And then think about it again. Here. That is T full tracker, and I want to let's say make a red type. T-foo, it's not a tracker, it's just a T-foo. T-foo R. Okay, can't do the same thread cannot do a write log and then keep it and then do a read log. So we have to release the write log again. But in the meantime, let's write to it. I think this should just give me plain access to full T-foo, right? So I can just say access 42. Well, let's do 1, 2, 3, 4. And then let's log it again, but now for reading. And then you should be able to do assert T-foo R X equals 1, 2, 3, 4. Feeling that something is going wrong here, but it's not working. These these what and reds are not the base, the unlock base things. I think the T-foo is derived from unlocked, not from unlock base, so that's not working. I need to take the tracker type and then add them to the object tracker, I think. So this works, but here I'm using the tracker, yeah, so I have to use T-foo tracker. Red. And then I have to add that to it because it doesn't have it. So we have Tfood tracker is the object tracker. In threading, I'm going to need using cred is well, I need the cred of the base type. Not sure I need a type name there, probably. Now we have a red and a what as well. Yeah, maybe you need more, right? There's more. We have I think just this one is probably all the user needs. The red base is not needed, I think. See red what, right to read carry, yeah. Might be needed. Yeah. Missing type name. It's not in the thing that I just added it to, yeah, so might as well use them, right? Yay, that works. And then we have again, I could run it, see if it actually if the search doesn't fail. This thing, yeah, works. So you can access it now directly and through the tracker, and yeah, the annoying thing here is that I'm pretty sure that this right locks it and then converts it to a red. So what you really want, of course, is that if you ask for a red, that you get a red. I can, however, do static cast, and then I'm sure that it just converts it to a red directly, I'm thinking. That should work. But yeah, then again, now it's going to do a copy, right? Or not? No, it's not. It's not going to copy. I mean, it creates a red here, that's true. I mean, I cast it. Okay, what's happening here? I think this cast is going to use the operator red that I just added. Show it. So that's an object tracker. Namespace threading. So because I use the cast, it's going to use this one. So, oh my god, I have an object tracker and you want a red. Well, how do I get that? Now it could do this one, called a what, and because what is derived from red. But I think it's just, you know, even though it's not const, it's going to use this one because I really cast it to a red and it's just going to use that one. Which is not possible if I call this. If you call this, it's always going to use this one because it's not const. In order to use this one, I would have to cast the object to a const one and then call the tracked unlocked. That would work as well. And yeah, I don't think that's what I want. If you get what I mean. I mean, it's I don't want to use cast everywhere just to get what I want. So I think that this is not a good interface. I need to explicitly say what I want. And give these things a different name. Plus, it's not unlocked me. It's not unlocked anyway. You know, it's like. Let's call it. It's not unlocked. It's a red. So like that. And this is a tracked what. And these are highly dubious because normally you would say if I have a function that takes a red, then I don't have to call that. I can just return, just pass the current object, and then the conversion is automatic. But yeah, if the current object is non-const, it's going to call this one and then pass the what, because the what is derived from the red and it's working anyway. I think, maybe it's not the case actually. Maybe you should check that. It's returning it by type. Yeah, I would have to check if, I don't know. Okay, let's check it. I'm gonna go to one box. So we have a struct A. And this is difficult. Let's see, this is my base class, and then I have a struct A derived from B. And then I have a function that takes B, probably const reference. And then I have a struct C. And that struct C has two functions, one returning a B, call it G, which is const, and the other one returns an A, which is non-const. And I want to know which one is called, right? So I print that out, and it's there. This is called G const is called. This one prints that G non-const is called. And then we have a main. And we wonder if I have a non-const C and I pass the C to, well, not C, CG. Yeah, of course this is going to call that one. It doesn't interest itself at all that f takes a b. It just looks at this, period. Oh, you want to call c? C is non-const. Okay, we're going to call that one. And then it's going to look if maybe, you know, it works, if it's convertible to that B const reference or not. So I run this, it's definitely going to say that it doesn't compile. Why not? Or return statement. Oh, wait a minute. To print that it's calling G, not G const. Yeah. However, it might be slightly different if we change this into an operator, right? So I'll make it now an operator, the B, and an operator A. And now it's different because I'm not explicitly calling G anymore. I'm just trying to pass C to F. So now it definitely has to look at the F, I think. Yeah, I think this is different. It's not going to say, oh, you want to pass C, let's call this. No, maybe F takes a C. So it has to look at the F and then see that F wants a B const reference. And then maybe it's going to call that one in preference to this one, even though C is not const. It's definitely a difference there. And the verdict is shit. That's still calling a non-const function. So I guess that what's going on here is that it says, okay, we need a B const reference. Does this one work? Yes. Does this one work? Yes. Which one shall we call? Well, the one that is non-const. Or maybe what happens if F just takes like literally the thing that we pass, that we return here? Still G. Doesn't want to do it. And if this one doesn't exist, it still compiles, I guess. Yeah, now it calls the console. Okay, well, now we know that. Then I think that this automatic conversion is just bad. Because you might take the write log while the function takes a read log. That's stupid. Don't want that one, for sure. And then this one I could still keep, but well, why not? Why not have that? I mean, yes, you know, well, no automatic conversion there. Just have to type it in full what you want. Tracked read, tracked what? Okay. So we can write that, go back. So now this does not compile anymore. Let me just check that. Does not compile. Problem is there, which is this line. So instead, now we have to do track read, right? And this thing returns a read, but that then is a temporary-ish. It's It's an R-value reference. It's not going to move it though. It's just using copy elation. I think it's with C++ 20 it's guaranteed to not copy. So what it's going to do is that it allocates red on the stack and then uses that allocation for the return type. So it just constructs it directly into this thing here. It's not going to create a temporary and then copy it. I'm not even sure I can copy a red. I don't think I can copy it even. No, reds cannot be copied. But it still compiles. So what I just said happens. And this then is kind of perfect, I think. And then, well, normally I create those things like reds are created with braces. And then at some point you say, well, it would have been definitely nicer looking if I didn't have to do that. But, well, it's kind of necessary, I think, because you have to explicitly state if you want to get the right lock or not. Unfortunately, I mean, if I take the write log and then convert that to a read log, that would still compile. And the other way around, it even works. If I take the read log and then try to construct a write log from it, then it's going to read log it and then convert the read log to a write log. So then it's going to read log it and then going to write log it. So it's still compiled. So if you make a typo there, then whoops. But okay, that would be stupid. Shouldn't do that. Of course, you can also still use a C-red here. The red is just a red is derived from a C-red, so but I think that in this case it's not the same type, so now it makes a temporary red and then constructs a C-red from the red and then destructs the red. So it might actually be slower on this. Let me see, C-red is a constant read access type, which could, for example, be, let's use this one. Huh? What was my constant read access type? Access const. I wasn't looking for this one. No. Primitive access. Primitive ref, primitive one thread. Read write. I don't have a const read access. Yeah, const read access. Why did I not find that one? Well, that is a const read access. No. Oh, it is. Read access. Sorry. Oh, it's using the move constructor, so it's not that bad. So we construct a red, which is a read access, and that's a temporary. So then the C-red, which is the const read access, is being constructed from that because the red is derived from the const read access and it was a temporary. So we are going to use this constructor. which as you see is, yeah, instant, nanoseconds. So it's still fast. Okay, now the thing that doesn't work is that my tracker is currently pointing to this tfoo here, or to the base class of this tfoo. It's pointing to the locked tfoo. If I move it, let me first write to it. So here we write 1, 2, 3, 4 to it. And then I'm going to move it. So we make a second tfoo, which move the tfoo away. And I want to make sure that I won't see that there's still 1, 2, 3, 4 inside of it. And that's just kind of difficult because I can't access it anymore. It's like, well, no. Well, we can cheat. We can horribly cheat. This is like really bad, but I can make a locked tfoo pointer hack access, and at the moment I have my write access, I can keep a pointer to it. So the write access type must be dereferenced, and then you get a reference to the locked tfoo. And then I can take the pointer of that again, and then we have a pointer that points to the locked tfoo. And then even after destructing the write access, we still have write access. Ha 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 ha. So that's really, really bad what I do here. Even worse, then I move it. And even though I moved it, it's still there. It's still on the stack here. So the thing still exists, so I can override it now. Hack access. X is, I don't know, let's make this 666. Now my tracker should automatically have been updated to point to the new tfoo. So this should not assert, but I think I'm like 100% sure that my tracker was not updated and it's still pointing to this tfoo. So now it's equal to 666, even though it was moved. Doesn't really mean much. It just means that yeah, I don't know, maybe the move does something already, I'm not sure. But if it doesn't, then it's still there, and we can still do this, and we can still do everything. And it's just going to say that the 666 is unequal 1, 2, 3, 4. So we should assert either that, or we crash because the move did set the base pointer to null. Now I think about it, it probably does that. So I guess that here we are going to get a null pointer. Maybe an assert, maybe a crash instead of an assert. Well, assert there anyway. What do we have here? Doesn't compile. One, 3, 5. Okay. I see I've. Oh, a second ago I had 0 viewers. Well, let's continue. 135 static cast from threading tracked object-t-foo into two, which are not related by inheritance, not allowed. Out of nowhere, suddenly. Why? I'm kind of scared that I did write again something that is pretty hard to use, because if you make a little mistake, you get this kind of error, and then any arbitrary user would say, okay, I'm not going to use this. Take some effort to understand what you did wrong. And I'm getting tired. I think I'm going to stop, eat some pea soup and watch a movie and then go to bed. But a second ago it compiled, so I want to understand why now suddenly I get this error here. Okay, let me read it. Set a cast from util threading tracked object-t-foo. You also use object tracker t-foo unlocked&lt pointer to object tracker oh wait, it's a type name of the object tracker t-foo unlocked. Suddenly it just leaves away the namespaces in this part. Very inconsistent. But I think it's the same type. And then tracked unlocked type pointer, aka threadsafe unlocked locked t-foo. Pointer. Which are not related by inheritance is not allowed. I think the unlock should not be there. Why did it not run into this before? Do I have two set of costs? I do. No. Oh, this is this is the move. Yeah, we didn't do a move yet. This is the first time I do a move. That's why I run into it now. Yeah, it should be the same as this. So just unlock too much. Dereference too little, I think. Not tracker set tracked unlocked. What did we pass here? I just bullshit, man. What's happening here? Oh, I'm not supporting it yet. Yeah, okay. I'm getting it. This is supposed to be passing a tracked unlocked type pointer. Well, at least that's what we're supposed to store. So the pointer embedded into this object here should be updated. And that's initialized with tracked unlocked, which is actually a tracked unlocked type, which is an unlocked base, I think. No, it's not. No, this is an unlocked base. Yeah, the unlocked base is constructed from that thing. So then we have internally a pointer to this thing here, or base class of that thing, sorry, base class of this thing. So I want to pass the same type, probably. Yeah. I can pass it as a pointer, why not? Pointer or constructor, doesn't really matter. And in this case, we have this pointer. This pointer is the new place of the tracked object. That is the base class of the object. Well, if I cast it to track type, that should work instead of track unlock type. So now we have the track type as a pointer, and I can pass that to set tracked unlocked. Because it should also be derived from tracked unlock type. And then if it isn't, then nobody will ever be able to fix this, except me, of course. Or I have to add more comments, maybe. I don't know. Nothing at all. Okay, we aborted because it's not equal. Well, that's pretty cool. I guess the M base was not set to 0. So I think it's simply equal to 666 now. I guess I could print that here. There's my keyboard. So dark here, I can't see anything. Success! That doesn't print anything. I guess I don't have debugging on. Yeah, it's 666. So there's just one tiny little thing to do, and that is make this work by making the update work when you move it. So here we have a t-foo which is moved, and t-foo is derived from tracked object. Therefore we call this, therefore we call this, therefore we call this, and then the other namespace. So we call this set tracked unlocked, and then we run into my fixme. And my fixme now has to update the base pointer of tracked unlocked, and we are locked, right? I mean, that's important. At the moment this happened, we are locked. Why are we locked? Because we are moving in yeah, I don't know, but it must be locked. It's actually a good question. Are we locked? No, we are no longer locked. We are no longer locked. Why not? Because we're only locked while moving the unlocked. And for some bloody reason, for the first time, exactly when it matters, use a base class. For unlocked is a base class. Unlocked should be the most derived type. So while moving tfoo, say tfoo is being moved, then what happens is the unlocked is being moved, and if the unlocked is being moved, we lock it. See if I can find that one back. This one. So it's going to lock it. Sorry, it's going to move the unlocked, which calls do write lock on original. Then moves it. Well, then moves t, and then call do write unlock. So it's write locked exactly while moving the unlocked. But that means that it's no longer locked while moving the tracked object base class. Ugh. Yeah. And if we make this part of that type, then suddenly we can't do the static cast anymore. Unless I specifically add the class that's doing the static cast as a friend. Could do that, I guess. Theoretically could do that. Or I have to manually do the unlock. I could do the unlock here. So then moving this will lock it, and then we have to... I would have to add a move constructor here that has a body that unlocks it again. Then it's also locked while doing the tracked object. I don't like that. I do not like that. Yeah, okay, that's a tracked object. So we remove it here and add it here, where it was before. Then it becomes a base class of locked tfoo, which is a base class of unlocked. Then it's, I think, going to be locked during the move, right? Even during tracked object. Yeah. Is it? Yeah, it is. But then my static cast fail. Okay, we can fix that maybe with a friend. I think I want to commit this before I make that change, because it's kind of a gamble thing. Yeah, and I'm going to stop for now. I'll do this tomorrow. This is work in progress on threading tracked objects. That's what I did today, I guess. There's a fix me there. Oh yeah, that's the fix me. Okay, get commit all vip. And then I have a git status here with a little divvy. And just a test program, a little test program. Can commit that as well, I suppose. Vip. Good. And then yeah, I could try to let's try this. So I want to get rid of this one. Add it here. Almost no difference, you would think. No, using I've got something. I think I can guess what it was. It must be Tifu here. So expect a compile error that the static cast is not allowed? Or what? Type dev redefinition. Oh. Oh, it must be forward declared. No, I can reverse it. It even starts to look maintainable now. And the error is tracker as a protected member. What? Oh, right. No, you're going to be kidding me, right? Okay. Yeah. Well. Yeah. Instantiation of member function in instantiation constrained by. What is this? More things go wrong than I had anticipated. Oh, it's pointing to the static cast after all. Cannot cast protected base class. Tracked object. Okay, so the question is where are we and who do we have to well, you know, to befriend, as it were, to be allowed to access the private parts of that person. Object, I mean. VI. Static class is there. So this is the one that needs to be a friend. It's pretty damn annoying. Yeah, it is extremely annoying that I have to add this clause as a friend. Especially because it is a specialization of a class that is also has a requires object tracker. Which in turn is a specialization of unlocked, and we must be a friend of that one, of unlocked. Now, let's begin. Now we're talking about tracked object. It's already for declared here. Tracked object has a static cost, 2 static costs. Okay. So these two has to be removed, or rather moved to before unlocked. Which means I need a for declaration of unlocked. Which we have here. Template requires is specialization of thread safe unlocked. That should still work then. And then tracked object is specialization object tracker, which is there. I think that should work as long as I have is specialization of. Yep, we'll already have that. And then, my friends, I need to add it as a friend. To unlocked. Yeah, hopefully that's going to work. I have no clue. Let me try this. Make. No, it doesn't look too bad, but what's going on here? Error. Call to implicitly deleted copy constructor of locked tfoo. In instantiation of member function unlocked locked tfoo unlocked requested here. Copy constructor or locked tfoo is implicitly deleted because base class tracked object aka is a deleted copy constructor. Oh. Copy constructor is implicitly deleted because the tracked object blah 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 as a user declared move constructor. Yeah, not only that, I'm pretty sure I deleted the copy constructor as well. No, I didn't. Tracked objects. Okay, that's interesting. Well, obviously I should be able to copy an object that is derived from tracked objects, right? So copy constructor is just missing, but wait, why am I here? Threading. Yeah. Yeah. Well, so we need a copy constructor here. But what should it do? You cannot copy it. You cannot copy it. Well, you can copy it, but then I have to make a new tracker as well. And I have 2 trackers. Can hardly believe that's what I want. No, that cannot be good. So then the question becomes, why the hell am I copying it? Call to implicitly delete the copy constructor of foo. I'm moving stuff. What are you talking about? In instantiation of member of move, and it's talking about copying. Yeah, okay. The end of the stream because I'm